Let's look at graphing the function f of x equals 2 raised to the exponent x. This is called an exponential function because the variable is in the exponent. So let's look at some points you could get on this. If we looked at, say, -4 through 4. Recall that anything raised to the power 0 is always 1. So for any function where we have a constant raised to a variable, if it's just the plain constant raised to the variable, it's always going to contain the point 0, 1. That's standard. And anytime the exponent is a 1, a raised to the first is going to be a. So 2 raised to the first is 2. And we know 2 squared is 4, 2 cubed is 8, and 2 to the 4th is 16. 2 to the 5th would go all the way up to 32. A negative exponent, recall, is going to be the same as 1 over that with a positive exponent. So 2 raised to the -1 is 1 over 2 is 1/2. 2 to the -2 is 1 over 2 squared, 1/4. -3 gives us 1/8. -4 gives us 1/16. So let's look at how some of these points would look on a graph. Okay, so we start with the point 0, 1, which should be right about here. And we're graphing f of x equals 2 raised to the x. So when x is 1, the y value is 2. When x is 2, the y value is 4, be about there. 3 would give us 8. 4 would give us 16. 5 would jump all the way up to 32. So we're going like this, and it's getting steeper really, really fast. It looks a little like a parabola at this point, but what happens on the other side? If x is -1, the y value is 1/2. -2 gives us 1/4. -3 gives us 1/8. And even though this looks like it would eventually go through the 0, it can't. Because 2 raised to any power can never equal 0. If it's a positive, it gets really big. If it's a 0, it's 1. And if it's a negative, it becomes a fraction, but with 1 as the numerator. And the only way a fraction can ever equal 0 is for the numerator to be a 0. So an exponential function looks kind of like this. If we were to look at 3 to the x, we would still have the point 0, 1, but then this would go to 3, this would go to 9, 27 would be up here somewhere. So 3 to the x would get big even faster, and small even faster. 4 to the x would get big even faster, faster, faster. What if we looked at, say, g of x, call it something else, equals 1/2 raised to the x? Well, 1/2 raised to the 0 is still 0. I mean, still 1. 1/2 raised to the negative 1 is 1 over 1/2, which actually turns out to be 2. So a negative 1 would give us 2. A negative 2 would give us 4. A negative 3 would give us 8. So we get the red graph reversed around the y-axis. And this would now flatten out this way. And this actually makes sense because negative 1/2 raised to the x, sorry, this makes sense because 1/2 raised to the x, 1/2 is the same thing as 2 raised to the negative 1. And when you've got a power to a power, you multiply the exponents. So 1/2 raised to the x is the same thing as 2 raised to the negative x. Changing the sign on the x would switch it around the y-axis. And so if your base is between 0 and 1, your graph's going to be decreasing all the time. If your base is between 1 and infinity, your graph's going to be increasing all the time. The domain, in any case, the domain of an exponential function is all real numbers. The range of a basic exponential function is always going to be from 0 to infinity. And you'll notice since it can't ever get down to 0, we have a horizontal asymptote. Of the x-axis, which is the equation y equals 0. And that's the basics of graphing an exponential function.